So this mini lesson is on scatter plots and correlation, and I'm actually going to be splitting it into two parts. So this part will be on scatter plots. So a scatter plot is essentially a graph that uses dots and x, y coordinates to represent data. And the position of the dot is just where the coordinate would be. And scatter plots are used to observe relationships between a variable and can help you figure out if there is a correlation. So an example of a scatter plot is something like this. So this is just height and weight. And so each of these dots would have an x coordinate and a y coordinate. So the x coordinate in this case is weight. The y coordinate in this case is height. The x coordinate is always your independent variable, and your y coordinate is always your dependent variable. And so each of these dots just represents a point where the weight and height would line up. So for example, if a person had a weight of 150 pounds and their height was 160 centimeters, that would translate into a dot on this graph. How do you make a scatter plot? Well, remember a couple of things. So first of all, I'm going to kind of bounce around a little bit on this. So when you make a scatter plot, the independent variable is the x coordinate and the dependent variable is the y coordinate. Remember that an independent variable is what you think might be the cause, and the dependent variable is what you think might be the effect. So in this case, an ice cream shop is wondering if the temperature outside will impact ice cream sales. And so they're tracking that every day. In this case, the independent variable is the temperature because they think that maybe the temperature is causing the ice cream sales to go up or down. And so the dependent variable is the ice cream sales. So when you make a scatter plot, you basically just take your dots, make sure you choose an appropriate scale, make sure your scale is consistent, make sure you label your x and your y, and now you would just graph it with dots. And so you can see the same data that was in the table is now presented to you in a graph. And it's a really easy visual way to see if there is a trend. So is there a trend? Well, what we do to find a trend is we draw something called a line of best fit. And a line of best fit is basically just the general direction that a group of points seems to follow. When you make a line of best fit, you try to include as many dots as you can or get as close to the dots as you can with trying to have about an equal number of dots above and below the line. And that line of best fit can help you to make predictions about your graph and what you see. For example, what if they wanted to find out what the sales would be if the temperature was 21 degrees Celsius? So you can use the line of best fit to make that prediction. And interpolation is making a prediction about a value that would be inside the data point. So in this case, 21 degrees is inside the data. So we can take our line of best fit, find where 21 is, go up, and basically hit the line, and go across and figure out approximately how many sales that would be. Now, what if they wanted to make a prediction about sales if the temperature were 29 degrees? Well, 29 degrees falls outside of the data set. So we need to use something called extrapolation, which is predicting something that falls outside of the data points. And to do that, all you need to do is extend the line of best fit. So in this case, we just draw the line a little bit longer. We find where 29 might fall. We go up to where the line would be if that trend continued. And we make a prediction about what the sales might be. Now, obviously, there's only so far that you would go. And maybe there's a point at which, it doesn't matter what the temperature is, the sales level off. This is just a prediction. It doesn't mean that it will actually happen. The other thing to keep in mind with a scatter plot is sometimes you have values called outliers, which basically means a value that will be much smaller or much larger than some of the other data points. And essentially, if you have something like that, if you have one point that just doesn't seem to match the others, you just ignore it when you're making your line of best fit, and you ignore it when you're making predictions. So for example, if you were looking at, I don't know, someone's height and shoe size, most people that are taller have a bigger shoe size and that are shorter have a smaller shoe size. But there's probably someone out there that is, really tall but has smaller feet, or a little bit on the shorter side but has big feet. They would just be outliers, and that's okay. That happens. The general trend will show kind of what's happening overall, and then you just kind of ignore the outliers. So that's a little bit of a summary of a scatter plot.